All right, guys, so today for the practice you guys are going to be doing and the proofs you're going to be working on, we're just adding one more property that we haven't talked about in class yet. So that property that we're going to talk about is called, it's actually one of the definition of ones, but we use it so much and it's kind of used in a different way, so I like to put it as its own postulate, is definition of congruent. So there's been a few times in class that we've talked about the difference between congruence and equals, and I've said eventually down the road when we get to proofs, we're going to talk about that in more detail and it's going to make more sense, and that day is today. So equals and congruence are two things that are very, very similar, but they're just used in different ways. So we've talked before about if you're talking about equals, when you're doing equals, you're talking about the measure of something. So that's when you're actually talking about the values, like BC equals 10, or the measure of angle A equals 70. So things you'll see written with equals are things like I just said, BC equals 10, or AB plus 5 equals BC, or the measure of angle B equals 50. Things where you're adding, subtracting, you're actually doing math, and you're talking about values. On the other hand, congruence is where you're going to see things like angle A is congruent to angle B, or AB is congruent to BC. Something you will never see is something like AB plus BC is congruent to AC. That will never happen because congruence is not used to add and subtract. Congruence is talking about objects being exactly the same, whereas equality or equal signs are used to talk about the actual values of things, like congruence is not. So what you are going to do to use definition of congruent, the times you're going to use that, is anytime you need to switch from equals to congruent or congruent to equals. So an example of that could be maybe something like this. Let's say you are told that angle A is congruent to angle B. And maybe it's one of those problems like I tell you that A and B are complementary and you need to be able to substitute. You cannot substitute with congruence because I would be taking this and putting it into an equation, and we don't substitute angle A, we substitute measure of angle A. We don't substitute segment BC, we substitute a BC. So we've done everything in equal, so it's probably a little hard for you to even understand the difference because you haven't really seen the difference yet. But overall, you just need to know if it's in congruence, you cannot substitute. I can use definition of congruent to rewrite that statement and say that this means the measure of angle A equals the measure of angle B. Because that's what congruence and equals essentially mean, the same thing. It's just the way that they're used are different. So if you have congruence and you need to switch it to equals, you can do that using definition of congruent. Now I can take the measure of angle A and sub it in, or I can take the measure of angle B and sub it in. You can also go the other direction. Let's say I tell you that the measure of angle A equals the measure of angle B. Maybe we get to that part in a proof. But the given or the prove statement is asking me to finish and say that A is congruent to B. I could go this way and say, okay, if those are equal, they're also congruent by definition of congruent. That's what it means to be congruent, is they have equal value, okay? So what we're gonna do to start out and kind of make this a little bit more realistic for you is I gave you a definition of congruent examples handout. It looks like this. And what I did was I took proofs we've done before with the work already written there that we've done in class or you've done for practice, and I just made one little change that shows you how it could be different if you have a congruent symbol thrown in there and how to deal with it. So in this video, we're gonna go through this first example, and then I'm gonna start another video just because I can only have a certain time length before it stops. And the second video, we'll go through the last three examples. So a lot of these steps are gonna be the exact same. It's just one little congruence is thrown in there and you have to see how you can work around that and make sure you're still using equals when you need to and congruence when you need to. So for this first one, you're given that the measure of angle 2 equals the measure of angle 3. And you need to prove that the measure of angle 1 equals the measure of angle 4. So when we went through and did this before, we used linear pair postulate. We said 1 plus 2 equals 180. We said 3 plus 4 equals 180. And this is one of those ones where if they're both equal to 180, we could just set them equal to each other. We have 1 plus 2 equals 3 plus 4. We want to end up with 1 equal to 4, but we can't subtract because we don't have the same term on both sides. So we can use substitution because they told me that 2 equals 3. I can use substitution to make these the same, and then use subtraction to cut those right out and be left with 1 equals 4 and be done, okay? So if we compare that to what's on the other side, The only thing that's different is in this new example, it says given angle 2 is congruent to angle 3, where here it said 2 equals 3. And again, this is new for you. So to explain the difference, 2 equals 3, we can sub right in. It's in equals, so I can use that and substitute. 2 congruent to 3, I cannot substitute congruence into an equation that has equals in it. Okay, so we're gonna have to take a step where we change this angle 2 is congruent to angle 3 into an equality statement. Okay, so if we were gonna start this proof, again, a lot of these steps are gonna be the exact same. I'm given that 2 is congruent to 3. I still need to use that linear pair postulate because that's what let me say that measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 3 plus the measure of angle 4 equals 180. I still want to get 1 and 4 into the same equation because I want to show that 1 equals 4. So I'm going to go ahead and use substitution and say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And that's substitution. Now this is where it gets a little different. In the last example, I could take the fact that 2 was equal to 3 and sub it right in. But as I've said a few times, you cannot take congruence and sub it into something with equals. So I need to take an extra step, and this is the new step, where I say, okay, I know that angle 2 is congruent to angle 3. That also means that angle 2 is equal to angle 3. And notice those m's pop up. If angle 2 is congruent to angle 3, then the measure of angle 2 equals the measure of angle 3. And that's definition of congruent. All I did was take the same information and flip it into equals. Now I'm ready to take this substitution and replace either angle 2 or angle 3 so that I have something to subtract. So now I can have that the measure of angle 1 plus the measure of angle 2 equals measure of angle 2 plus the measure of angle 4. So I substituted right there. And lastly, I can go ahead and say that 1 equals 4 by subtraction. So the entire process is the same, except for just that one extra step, because congruence and equals are not compatible. They're like two different languages. So if this is in terms of equals and this is in terms of congruent, you just have to change it into equals and then you can make that substitution.